You're wearing their products right now. Your phone runs on their tech. Your car, your computer, your coffee machine, all connected through their invisible infrastructure. Yet if I asked you to name this company, you'd probably draw a blank. And that's exactly how they want it. Look, we spend so much time obsessing over Apple's latest iPhone or Tesla's stock price. Meanwhile, there's this quiet giant that touches your life dozens of times every single day, and you have no idea it exists. They don't advertise. They don't compete for your attention. They simply run everything. So buckle in. Today, we're diving into the invisible empire of ARM Holdings, the company that powers 99% of smartphones on Earth, and somehow almost nobody knows their name. Let me take you back to 1983, and something unremarkable is happening in Cambridge, England. A small British computer company called Acorn is struggling. They need a processor for their new computer, but the options available are too expensive, too power-hungry, and frankly, not good enough. So they do something that seems crazy at the time. They decide to design their own chip from scratch. Now, this wasn't some Silicon Valley moonshot backed by venture capital billions. This was 12 engineers in Cambridge working with limited resources, forced to think differently because they had no other choice. And that constraint? It became their superpower. While Intel and Motorola were building increasingly complex, power-hungry processors, Acorn's team went the opposite direction. They created something radically simple, elegant, efficient. They called it the Acorn RISC machine, or ARM. RISC stood for Reduced Instruction Set Computing, which basically meant stripping away everything unnecessary and keeping only what mattered. The first ARM processor used just 25,000 transistors. For context, Intel's chip at the time used 275,000. It was so efficient that the prototype ran correctly the first time they powered it on, which almost never happens in chip design. In fact, it ran so efficiently that they couldn't figure out why it was working. Turns out, they'd forgotten to connect the power supply. The chip was running on electrical leakage alone. That moment defined everything ARM would become: extreme efficiency, minimal power consumption, maximum performance per watt. But here's where the story gets interesting. Acorn realized they'd built something special, but they also knew they couldn't scale it alone. So in 1990, they made a decision that would change everything. Instead of trying to manufacture and sell chips themselves, they did something almost no one was doing at the time. They decided to just license the design. Think about that. They wouldn't make chips. They wouldn't sell chips. They'd simply sell the blueprints and let other companies build whatever they wanted with them. This was revolutionary. ARM became the IP company, the architecture company, the brains behind everyone else's brawn. And this model is precisely why you've never heard of them, even though you use their technology every single day. Apple didn't create the processor in your iPhone from scratch. They licensed ARM's architecture. Qualcomm's Snapdragon chips in Android phones, built on ARM. Samsung, Huawei, MediaTek. Every single smartphone chip manufacturer in the world builds on ARM's foundation. But it goes far beyond phones. Your smart TV runs on ARM. Your router, your fitness tracker, your car's entertainment system, your smart thermostat, your wireless earbuds, all ARM inside. In fact, over 250 billion ARM-based chips have been manufactured to date. That's more than 30 chips for every person alive on Earth, yet ARM employs fewer than 7,000 people. For comparison, Intel employs over 120,000. How is this possible? Because ARM doesn't manufacture anything. They design, they innovate, they license. Their customers do the rest. It's the ultimate leverage play. Maximum impact, minimal overhead. And here's what makes this even more fascinating. ARM doesn't just license one design, they offer an entire ecosystem. Want a chip for a fitness tracker that needs to run for weeks on a tiny battery? ARM has a design for that. Need a high-performance processor for a laptop? They've got that too. Everything in between? covered. This flexibility is why ARM architecture now dominates mobile computing with over 95% market share. While Intel spent decades trying to get into smartphones and failed spectacularly, ARM quietly became the standard that everyone else had to follow. But the mobile revolution was just the beginning. Something much bigger is happening right now, and it's why ARM's influence is about to explode even further. You see, for decades, personal computers ran on x86 architecture, which is Intel and AMD's territory. ARM was the mobile chip, not the desktop chip. But that boundary is collapsing. In 2020, Apple shocked the industry by announcing they were ditching Intel processors in their Macs and switching to their own ARM-based chips. The result? The M1, M2, and now M3 chips that are faster, more efficient, and more powerful than the Intel chips they replaced. Suddenly, ARM wasn't just for phones anymore. It was powering the MacBook Pro that video editors depend on, the Mac Studio that 3D artists use, the servers running AI workloads. Microsoft saw this and responded by pushing ARM-based Windows laptops. Qualcomm is now making ARM chips for PCs. Amazon's AWS uses ARM-based Graviton processors in their data centers because they're more efficient. Google, Microsoft, every major cloud provider is shifting toward ARM. Why? Because in the age of AI and cloud computing, power efficiency matters more than ever. Data centers consume massive amounts of electricity. ARM's efficiency advantage that seemed like a nice bonus in phones becomes a competitive necessity at scale. We're talking about billions of dollars in energy savings. But behind this technological dominance, there's a strategic vulnerability that most people miss. You see, ARM might be everywhere, but they don't actually control their own destiny. Not anymore. In 2016, Japanese conglomerate SoftBank acquired ARM for $32 billion. Then in 2020, NVIDIA tried to buy ARM for $40 billion. That deal fell apart under regulatory pressure from governments around the world who realized that letting one company control ARM would give them too much power over the entire tech industry. So, in 2023, ARM went public. They're now traded on the NASDAQ, valued at over $150 billion at their peak. And caught in this geopolitical chess match between the United States, China, Europe, and everyone else who depends on their technology. China is trying to develop alternatives to ARM because they're worried about losing access. The U.S. government has restricted ARM from licensing certain technologies to Chinese companies. Europe is funding initiatives to reduce dependence on foreign chip architectures. Everyone sees ARM as critical infrastructure now. And here's the paradox. ARM's business model, licensing designs instead of manufacturing chips, was supposed to make them neutral. They don't compete with their customers. They enable everyone. But that neutrality is now their biggest liability. Because when your technology becomes this essential, geopolitics doesn't care about your business model. Yet despite all this pressure, ARM keeps growing. Their revenue model is beautifully simple. They charge upfront licensing fees when a company wants to use their designs, then they collect royalties on every chip that gets manufactured. As the world makes more devices, ARM makes more money. No factories, no inventory, no supply chain headaches, just intellectual property generating billions in revenue. And the future looks even bigger. The Internet of Things is exploding with billions of connected devices coming online. Every sensor, every smart device, every autonomous vehicle needs processors. Most will run on ARM. Artificial intelligence is moving from centralized cloud servers to edge devices, your phone, your watch, your home assistant. Those edge AI chips? ARM-based. Even in areas where ARM wasn't traditionally strong, they're making moves. They're pushing into the data center with designs optimized for cloud workloads. They're working on chips for autonomous vehicles. They're expanding into networking equipment. Anywhere computing happens, ARM wants their architecture to be the foundation. But here's what keeps me up at night about this story. We've built our entire digital infrastructure on top of one company's architecture. That's never happened before at this scale. Intel dominated PCs, but ARM dominates everything. Phones, tablets, embedded systems, and now they're coming for PCs and servers too. What happens if ARM makes a critical mistake in a design? What if their next architecture has a fundamental security flaw? What if geopolitical tensions force them to stop licensing to certain countries? The ripple effects would be catastrophic. Your phone might stop getting updates. New devices couldn't be manufactured. Supply chains would freeze. This is the invisible empire's weakness. Power concentrated in one architecture, controlled by one company, caught between superpowers who all need it, but none fully trust it. Yet despite everything, ARM keeps winning. Because once an architecture becomes the standard, the switching costs are enormous. Billions of lines of code are written for ARM. Millions of developers know how to optimize for ARM. The entire mobile app ecosystem runs on ARM. You can't just swap that out overnight. So we're left with this bizarre situation. ARM is simultaneously the most important tech company you've never heard of and the most vulnerable. They touch your life constantly, but remain invisible. They enable everything, but control nothing. They're worth over $100 billion, but employ fewer people than a mid-sized manufacturing plant. From a scrappy British startup building chips in Cambridge to the architectural foundation of modern computing, ARM's journey is a masterclass in leverage. They proved you don't need to make things to shape the world. You just need to design the system everyone else builds on. But that brings us to a question that matters more every day. When one company's designs power everything from your smartwatch to the servers running AI, when their architecture becomes too essential to fail, who's really in control? The company that owns the IP? The governments that regulate it? Or the manufacturers who actually build the chips? The invisible empire doesn't have kings or crowns. It has instruction sets and licensing agreements. But make no mistake, it rules all the same. And if you want to see more stories about the companies that shape our world from the shadows, hit subscribe. I'm pushing to 100,000 and I'd really appreciate your support. Thanks for watching, and I'll see you in the next one.